Good day, Alphonsians. Last time, we have discussed how to solve systems of linear equations by graphing and by substitution. This time, we'll solve systems of linear equations by elimination. So we follow these steps when solving a system of linear equations in x and y using the elimination. First, write both equations in standard form, that is, the form ax plus by equals c. Multiply one or both equations by appropriate numbers so that the sum of the coefficients of either x or y is 0. Add the new equations to eliminate the variable. The sum should be an equation with only one variable. Solve for the value of the first variable. Substitute the result in step 3 into either of the given equations and solve for the other variable. And lastly, check the solution in both equations and write the solution set. Let's go to our examples. Now let's go to our example 1. Solve the system 3x minus 5y equals 13 and 4x plus 5y equals negative 6 by elimination. So now let's be reminded of our steps on how to solve systems of linear equations by elimination. So we have these 5 steps. Okay, now let's go back to our example 1. So here we have to check if both of our equations are written in standard form, that is in the form ax plus by equals c. So we have here 3x minus 5y equals 13, and we can see that first equation is already in standard form, so meaning to say there's no need for us to rewrite this into standard form. Second equation, we have 4x plus 5y equals negative 6. And like the first equation, second equation is already in the standard form. So meaning to say we are done with step 1. Now, for step 2, check if a variable can be eliminated right away. So we have here on our first equation, the term containing the x variable is 3x. On our second equation, the term containing the x variable is 4x. Now let's try to add 3x and 4x. Will it give us 0? Of course not. So meaning to say we cannot eliminate x right away. So now let's try to see if we can eliminate right away the variable y. In our first equation, the term containing the variable y is negative 5y. In our second equation, the term containing the variable y is positive 5y. So since we have on the first equation negative 5y, on the second equation we have positive 5y, and when we add negative 5y and positive 5y, will it result to 0? Yes. So meaning to say we can eliminate the variable y right away. So we will eliminate the variable y. Okay, so now we are done with step 2. Now let's proceed to step 3. So we have to add our equations. So we have here 3x plus 4x. That will be 7x. Now negative 5y plus positive 5y. Of course, it's 0. And since our sum is 0, let's not write 0 because it will not change anything in our equation. So we just have 7x equals 13, okay, plus negative 6. Okay, that is 7. So now we have 7x equals 7. Now let's write that properly. We have 7x equals 7. Now, solving for x, we need to divide both sides by the numerical coefficient of x here, which is 7. So divide both sides by 7. Divide both sides by 7. Okay, we can divide out 7 over 7, that is 1. So we just have now x equals 7 over 7 is 1. So the value of x is 1. Alright, so we are done now with step 3. Next, step 4, substitute the result in step 3 into either of the given equations and solve for the other variable. Now that we have already the value of x, now we will solve for the value of y. Now, you can use either of the equations given. So in this case, let's use the first equation, which is 3x minus 5y equals 13. So that will be 3x minus 5y equals 13, and then substitute the value of x that we had here, that is x equals 1. So now we have 3 times the value of x, which is 1, equals negative 5y equals 13. Alright, now solving for y, we have 3 minus 5y equals 13. To solve for y, we need to isolate negative 5y on the other side. So we have negative 5y equals 13. Transpose 3, positive 3 becomes negative 3. So we have 13 minus 3. Continuing with our solutions, we have here negative 5y equals 13 minus 3, that's 10. Divide both sides by negative 5. Y now is equal to negative 2. Now we have already the value of y, which is negative 2. Alright, so okay, we are done now with step 4. Next, let's go to step 3. We have to check if the solution is correct in both equations. So we have here x is equal to 1 and y is equal to negative 2. Let's check our first equation. This is now the checking. So using our first equation, we have here 3x minus 5y equals 13. And our second equation is 4x plus 5y equals negative 6. Now substitute our solved values for x and y. So we have here for the first equation 3 times, okay, x is 1, minus 5 times x is negative 2 equals 13. Here we have 3 times 1 is 3, negative 5 times negative 2 is positive 10. So plus 10 equals 13. Now 3 plus 10 is 13 and equals 13. So meaning to say our values for x and y are true for the first equation. So check. Now let's go to the second equation, 4x plus 5y equals negative 6. Substitute our solved values of x and y. So you have 4 times 1 plus 5 times negative 2 equals negative 6. 4 times 1 is 4. 5 times negative 2 is negative 10 equals negative 6. 4 minus 10 is negative 6. That is just equal to negative 6. So meaning to say, our values of x and y are true for the second equation. Since our solved values for x and y are true to both of our given equations, so the solution is 1 and negative 2. Now let's go to our second example. So solve the system 2x plus 3y minus 7 equals 0 and x minus 2y plus 7 equals 0. Okay? By elimination. So step 1, we have to make sure that our given equations are in standard form. Now checking our given equation, 2x plus 3y minus 7 equals 0 is not in its standard form. Meaning to say, we need to rewrite the first equation into the standard form. So rewriting, that would be now 2x plus 3y. And since we have to transpose negative 7, that becomes positive 7. So equals positive 7. Okay, looking at our second equation, x minus 2y plus 7 equals 0. Still, this is not in standard form, so we need to rewrite this one into standard form. So rewriting, we have x minus 2y equals transpose positive 7, that becomes negative 7. Okay, so now that our given equations are already in standard form, now we can proceed to step 2. Now step 2, we need to check if we can eliminate a variable right away. So we have, let's check the variable x. Now 2x plus x, will it give us 0? Okay, no, it will not give us 0. So we cannot eliminate the variable x right away. How about the variable y? Now let's check. Positive 3y plus negative 2y, will it give us 0? Okay, no. Meaning to say, the variable y cannot be eliminated right away also. So since both of our variables can't be eliminated right away, then we need to multiply one of our equations by an integer that can make one of our variables be eliminated. Now in this system, let's try to eliminate the variable x. Okay, now here 2x and x. Now we know that if we have negative 2x here in our second equation, we can already eliminate the variable x. So our target here is that we'll have negative 2x in our second equation. And to do that, we need to multiply our second equation by negative 2. Okay, so multiply the entire equation by negative 2. So our second equation now will be negative 2x. This is following the distributive property of multiplication, plus negative 2 times negative 2y plus 4y equals positive 14. Let's proceed. Write again our first equation. We have here 2x plus 3y equals 7. And our new second equation, which is negative 2x plus 4y equals 14. Proceed to step 3. Add the two equations to eliminate the variable x. So we have 2x minus 2x, so that is 0. So x now is eliminated. So we have here 3y plus 4y, that is 7y equals 7 plus 14 is 21. Solve for y. Divide both sides by 7. Now y is equal to 21 divided by 7 is 3. So y is equal to 3. Okay. Now proceed to step 4. Okay. Choose any of the given equations to solve for the variable x. So here, let's use our second equation. The x minus 2y plus 7 equals 0. So solving for x, we have, okay, x minus 2y plus 7 equals 0. So x minus 2, substitute our solved value for y, which is 3. So times 3 plus 7 equals 0. So you have here x, negative 2 times 3 is negative 6 plus 7 equals 0. So x, negative 6 plus 7 is positive 1 equals 0. Now to solve for x, we should isolate x to one side of our equation. So we need to transpose 1 to the other side. So we have x is equal to, okay, 0, okay, 1 becomes negative 1. So 0 minus 1 is just negative 1. So x is equal to negative 1. Okay, now that we already have our values for x and y, we can now do our checking. So for the checking, okay, first let's have our first equation, that is 2x plus 3y minus 7 equals 0. So substitute our values of x and y. So 2 times x is equal to negative 1 plus 3 times 3 minus 7 is equal to 0. So 2 times negative 1 is negative 2 plus 3 times 3 is 9 minus 7 is equal to 0. So negative 2 plus 9 is positive 7 minus 7 is 0. So we have 0 is equal to 0, meaning to say our values for x and y are true for the first equation. Now let's go to our second equation, that is x minus 2y plus 7 equals 0. So x here is negative 1 minus 2 times 3 plus 7 equals 0. So negative 1, negative 2 times 3 is negative 6 plus 7 equals 0. So negative 1 minus 6 is negative 7 plus 7 is 0. So we have 0 is equal to 0, meaning to say our solved values for x and y are true for the second equation. And since they are both true to both of our equations, then meaning to say the solution to the system is x is negative 1 and y is 3. So we have negative 1 and 3. So that's it. That's how to solve systems of linear equations by elimination. I hope you learned something. See you in our next video.